Hi, I am Samikda and I will be solving question number 2 of homework 3. Okay, so what we have been given in question number 2, x is uniform in the range of a to b and the random variable y is equals to the square of the random variable x. So now for the first part we have to find the probability density function and the probability distribution function capital Fx. So the uniform distribution can be defined as Fx of x is equals to 1 over b minus a, where x ranges from a to b and it will be 0 otherwise. So if we draw the plot is a rectangle where x ranges from a to b with a constant value of 1 over b minus a. So now the probability distribution function can be written as 0 if x is less than a, x minus a over b minus a if x is a between a and b, and 1 if x is greater than b. So we can see for the graph of the probability distribution function, the graph can be drawn as a linear increasing function from a to b with slope of 1 over b minus a, and at b the probability distribution function will be 1 and it will be 1 so on. Now for the second part we have been given a equals to -1, b equals to 3. So probability distribution function fy can be written as probability y is less than equals to y, which is equals to probability x square is less than equals to y. Now fy y equals to 0 for y less than 0 since x square is non-negative. Now for y between 0 to 9, how the range 0 to 9 is coming? Because fx, the probability distribution on random variable x ranges from a to b, so the square ranges from 0 to 9, not 1 to 9. So now the fy can be written as y less than this and probability x square less than y. So this x square less than y can be written as probability of x between minus root y to root y. Okay, now for y equals to 1, 0 to 1, the distribution function can be written as f of root y minus f of minus root y, which can be written as root y plus 1 divided by 4 minus root y plus 1 divided by 4, which comes around root y by 2. Now for y in the range of 1 to 9, fy is f of root y minus root y. There is no minus root y component because x is not defined in minus of x is not defined for less than -1. So that's why for this f of y, this will be equals to root y plus 1 divided by 4, and for y greater than equals to 9, the distribution function will be equal to 1. So the distribution function fx y can be written as 0 for y less than equals to 0, root y by 2 for y between 0 to 1, root y plus 1 by 4 for y between 1 to 9, and for greater than 9 it will be 1. So you can see the curve from 0 to 1 it is root y by 2, and from 1 to 9 it is root y plus 1 divided by 4. Now the probability, now we need to find the probability density function. So the probability density function will be defined as the derivative of fy over y, fy over y. So the probability density function can be defined as dfy by dy. So it can be written as 1 over 4 root y for y between 0 to 1 and 1 over 8 root y for y between 1 to 9. So we can see there is a discontinuity for y equals to 1. So it drops from 1 by 4 to 1 by 8 due to the change of functions. So now for the last part is we need to find the expectation of y. So it can be written similarly as this, from minus infinity to infinity. So since y ranges from 0 to 9, so it can be written as this, as follows. And so the expectation of y is 7 by 3. Thank you.